Welcome to this AnalyzerPro tutorial. In this tutorial, we will learn how to use the collision analysis with the momentum forward calculation. You can find the example used in this tutorial on the homepage and the video description for download. AnalyzerPro offers several options to analyze a collision. Let's start with the collision analysis using the momentum forward calculation here. The momentum forward calculation is primarily used in situations in which relatively little traces are available, and you can only roughly estimate the collision location and the collision velocity based on damages and traces. Let's open the collision analysis with a click on the respective button. It opens the driving dynamics window, which we already know from the previous tutorial, as we are in the kinetics section in which forces are at work. At the same time, the window for the collision analysis is opened. By default, it opens up the small mask. There is also a big mask available. It can be opened via the menu modules and would feature additional input values. However, in our case the small mask is sufficient. You can also see that the first two vehicles are activated, and the intersection of shock tangents is shown. In this example, the traces are already drawn and the final position of the vehicles are marked. As a first step, we need to position the vehicles in their suspected collision position. In this case, it is relatively easy to estimate the collision place and to position both vehicles accordingly. In reality, it always needs a certain degree of trial and error in forward analyses, because precise starting parameters can only be found with incrementing and searching. Please note that the vehicles need to penetrate each other here. As a next step, we insert the velocity that we estimate based on the damages. It does not need to be the exact velocity of the collision, because that is exactly the aim of the calculation, to find this value out. In this fictitious example, we assume that the blue vehicle had a velocity of 35 km per hour and the red vehicle had a velocity of about 30 km per hour. If we now click on impact point, the impact tangent is automatically positioned in a way that it crosses the overlapping part of the vehicles, and the relevant vectors are indicated as well. With a click on play, I can now simulate the sequence as I have defined it before with the indicated parameters. I can immediately notice that although the two vehicles generally move in a good direction already, they roll out for quite a long time. This is obviously the case because I have not entered any kind of braking behavior so far, and the only deceleration is caused by friction and engine brake at the moment. As we have learned in the previous movie, we can specify the driving behavior in the simulation data. Therefore, let's open the simulation data again with a click on S, and indicate a braking behavior for our blue vehicle. I assume that the blue vehicle has braked heavily, so I assign a 90% brake pedal position to it. Afterwards, I change to vehicle 2 and assign a relatively strong deceleration as well, about 60% of the brake pedal position. If I click on play again and watch the simulation, I can see that the vehicles move in the final position much better already. However, the calculation is still not perfect. I could now continue to change the values, of course, click on play, view the result, and continue doing that until I have come to a reasonable result. This would cost me a lot of time and would also be inconvenient. That's why there is a faster method available, the Delta D button here. When we click on the Delta D button, we can see that the final positions of the vehicles are automatically shown. We can now click into one of the values we have entered before, and increment it with a click on the arrow buttons next to it. The special feature here is that with each increment a new calculation is conducted, and we see immediately how the driving behavior of our vehicle changes. This way it is easy to approach the right final position. Incrementing functions in the same way as discussed in the previous tutorial. When we use the arrow buttons, we increment the position on the far right, with the pressed Control key, one position before that, and with the pressed Shift key, the third position from the right. This incremental system works in the collision analysis mask as well as directly in the simulation data. In especially difficult cases, it is possible that you have to adjust several values until you come up with the desired end result. However, this method allows you to extrapolate to collision velocity and position, even though practically no traces are available. As soon as my final positions correspond well, the collision analysis with the momentum forward calculation is completed. Now we need to export our collision analysis and the coasting behavior into the kinematics section again, as we have already done it in the driving dynamics tutorial. Please click on Export here so that we can continue to calculate the pre-collision kinematically. Now we can close the collision analysis mask with OK, and we are in the kinematics mask again. A quick glance at the lower area of the monitor reassures us that we are in the kinematics window. It says Movie and in brackets Kinematics. If I click on Play, we could also watch the driving sequence now. When we open the main data mask now, we can see that the first 3 phases have been used for coasting and collision. 2 phases for coasting, here indicated as skidding, and 1 phase for the collision. In front of these phases, I can now insert additional ones. The possibility to insert phases represents one of the biggest strengths of AnalyzerPro, because you can completely avoid long and complex calculations with driving dynamics for the pre-collision. With this tutorial, you have learned the basics of collision analysis with the momentum forward calculation. Thank you for your attention.